So this is Mr. Garb with a little help video for your project. Just how to use Desmos. People ask me how to do that. Well, let's just say that you had a function that you got after you solve for r using the surface area, and you substitute it back in to your volume equation. Now instead of using v, instead of v I'm using y. Instead of using r, I'm using x. Okay, that's the way Desmos understands the variables. So if you type that in here, and let's just say this was the function after you replaced your value of h in terms of r, and you put it into the volume equation, and then before you take the derivative, before you differentiate, that equation right here, that'd be the red one. All right, so if you zoomed out and you left it like this, you might look at that and say, oh, it's a line, and it looks like a line at a distance. But if you zoom out actually, the volume is going to be a tremendous number. It's going to be like 1,000, 2,000. See, you zoom out, it's not really a line. So by hitting these little plus and minus keys, you could zoom out and zoom in. Also, if you know approximately where your max volume is going to be, let's say 2,000, then you can hit this little wrench here. Now you can continue to zoom out, but it's going to be really hard to see. But what's nice about this graph is that you could customize it. So you can go to the wrench, the graph settings, and let's say you calculated and you knew your the theoretical maximum volume was going to be somewhere around 2,000 something, right? So let's say you went 2,300 to 2,500, right? So you could break it down even more. Okay, so you can see right there. Now the x, you got to set the x by, so you can see it peaks right there. All right, now you can zoom in. You're zooming in here by hitting the zoom button plus. Now let's say you want to set the x parameters here, right? Because look down the x-axis. So you could also fix the x-axis parameters. So right now it's here to here. So let's say you figured out, well, let's do it. So taking this graph, it looks like if I took the tangent line, it would be around 7.3 would be where the derivative is equal to 0, right? So if you take the derivative, boom, right there, there's the derivative, and that's blue. So if you go down to the, you hit the house button to get back to the original. Look right there. See, the value of the derivative is 0. So it x equals, or the radius r equals 7.303. That's going to be the place where the derivative equals 0. So if I make a vertical line there at 7.3 and I follow that back up, so how do you follow that back up? Well, you can zoom out a lot, or you can just hit the wrench and say, hey, my max volume is supposed to be somewhere between like 2,300 and 25, like 2,400 or something. So you could say 2,300. So you're kind of knowing where to zoom in. This is not really cheating. This is just knowing where to zoom in. And then you set the x-axis. Well, you know it's going to be somewhere between, it was 7.3. So let's say it was between 10 and 10, 5, and 15. Just so it centers the graph. Now look at that. Isn't that beautiful? So there's your vertical line, x.73. The red line is your original function, is the function that you get after you substitute in the value of h in terms of r into your volume equation before you differentiate. And in your equation, you're replacing r with x, okay, and replacing v with y. That's the language that Desmos understands. And if you differentiate by using this blue function here, you'll follow down. That's the value of the derivative. So if you take the derivative right here, you can see the flat line will be right there. All right, and then you save this guy. Now, if you want to, you could put an email in here like I have, and I put your email in here. It doesn't send you anything or sell you anything, sell your information or spy on you. Then you'll have this, and you could of course just print it out, but you'll have the option to embed this in an image. So let's say you had a Google slide or a PowerPoint or a Prezi or whatever, some kind of digital format that you're making your poster in. What you can do is you can export the image or embed it, and you can put it in something else to make it look really fancy. It would be a nice graphic to put in there. And again, so all you have to do is put an email, and then you can save it. So like this is my optimization project help, and I have all these different videos that I've done for many years, which is kind of nice, and they're there for me when I need them. So that's a nice little feature. But again, it's the zoom. So just to refresh, go to the wrench, and you figure out where the derivative is supposed to be 0. Put that for your x-axis, and for your y-axis, that's going to be your max volume height theoretically, not the actual can, but the theoretical one. And then you can see that this graph's going to level off, and you wouldn't tell that just by looking at it because it looks like a line to start with, right? But you could see the green, the derivative equals 0 right there. Okay, it's 7.3, so that tells you what your x-axis should be. So when you go to the wrench, you know you should be centered around 7, so that's why I put it like 5 to 15 or 5 to 10. And then my y-axis, well, if I plugged in 7.3 into my volume equation up here, then it's going to give me something in the 2000s. Therefore, I need to go back here and change that. So I know it's going to be 2400. So let's say 2350 to 2500. And booyah, there it is. All right. And then you could save that image, keep it. There you go. So that's what I would do if I were you. All right, I'm going to save this and put it in the stream for you.